Okay, I'm going to discuss Descartes' rule of signs as well as the rational root theorem. And I will actually be solving an equation. Okay? So to get the Descartes' rule of signs for a polynomial form f of x would be the number of possible real roots is either the number of sign changes in the polynomial or 2 fewer, 4 fewer, etc. The number of possible negative real roots is either the number of sign changes in f of negative x, or 2 fewer, 4 fewer, etc. Remember that a negative x to an even power gives you x to the even power, because an even exponent implies multiplication of balanced pairs of negatives. Okay, so x squared would negative x in parentheses squared would be negative x times negative x would be x squared. X to the fourth would also give you a positive value. X to the sixth would also give you a positive value, etc. Okay, so negative x to an odd power would give you a negative value. Okay, well, negative x to that odd power. So to get the positive real roots of this, hopefully you agree that this is positive 1. Positive 1x to the 7th. So already, this is a sign change. Sign change number 1. Okay? So that's positive to negative. Well, that's negative to negative, so that's no change. Negative to negative, no change. Negative to positive. So that's number 2. And then that's positive to positive, positive to negative. That is number 3. So there are going to be 3 or 1 positive real roots. Okay, 3 or 1 positive real roots. Possible negative roots. All right, so that's going to be negative x to the 7th minus negative x to the 6th minus 6 to times negative x to the 5th minus 10 negative x to the 4th plus 9 times negative x cubed plus 71 times negative x squared minus 4 times negative x minus 60. All right, so negative x to an odd power gives you negative x to the odd power, so this is going to be negative x to the 7th minus, that's going to be x to the 6th, positive x to the 6th, minus 6 times negative x to the 5th is going to be negative x to the 5th. Okay, negative x quantity to the 5th is negative x to the 5th. Minus 10, negative x to the 4th will be x to the 4th, positive x to the 4th, plus 9 times negative x cubed, plus 71 times x squared, plus 4x minus 60. And then I'm going to clean this up. Okay? All right, so this will be negative x to the 7th minus x to the 6th plus 6x to the 5th minus 10x to the 4th minus 9x cubed plus 71x squared plus 4x minus 60. So, sign changes. That's negative to negative. That's no sign change. Negative to positive. That's sign change number 1. And then we went negative to negative, no change. Negative to positive, that was a sign change. Now we're going positive to negative. So that's number 2. Then negative to negative, no change. Negative to positive, that's going to be sign change number 3. Then positive to positive, no change. Then positive to negative, that's number 4. So there are 4. There will be 4 or 2 or 0 negative real roots. All right, so what we determined is that there are going to be, there's either going to be 3 or 1 positive real roots, 4, 2, or 0 negative real roots. Okay? So now I propose to solve this, okay, using the rational root theorem. So give me a moment, I'm going to move this table. All right. Looks like I'm doing fine for board space now. Move this over a little bit. Okay, so we're now going to solve x to the 7th minus x to the 6th minus 6x to the 5th minus 10x to the 4th plus 9x cubed plus 71x squared minus 4x plus 60. Sorry, minus 60. Let me double check it again. So to find the roots of that polynomial, we need to set it equal to 0. So P is all my factors of 60. That includes 1, 2, 3, 4, 5, 6. Okay, now 7 is not a factor, 8 is not a factor of 60, 9 is not a factor of 60, 10 is. All right, so we, as we were working our way up the factors of 60, we got a matching pair. So to get the rest of them, we just need to divide. Division by 12 by 5 gives me 12. By 4 will give me 15. By 3 would give me 20. By 2 would give me 30. And by 1 would give me 60. Okay, so those are all my factors of 60. Q is all my factors of the lead coefficient 1. So plus or minus P over Q would be all the P's over 1. So it just ends up being all the P's. Okay, so we will test x equals 1. So we will test x equals 1. So I'll do the synthetic division stuff. 1, negative 1, negative 6, negative 10, 9, 71, negative 4, and negative 60. All right? So I'll bring down the 1. 1 times 1 is 1, that's 0. 1 times 0 is 0. Negative 6. 1 times negative 6 is negative 6, that's negative 16. 1 times negative 16 is negative 16, that's going to be negative 7. 1 times negative 7 is negative 7, that's going to be 64. 1 times 64 is positive 64. That's going to be 60. 1 times 60 is 60. That's 0. So that's what we need, x equals 1. Now, having determined that that x equals 1 and as a root to the original equation, we now also have a quotient 1x to the 6th plus 0x to the 5th minus 6x to the 4th minus 16x cubed minus 7x squared plus 64x plus 60. I want to know if it also, I want to solve it for 0. Now, 1 worked in the original. I'd like to see if it might work in this one as well. Okay? So we got 1, 0, negative 6, because we're going to use this polynomial now. Negative 16, negative 7, 64, and 60. So bring down the 1. 1 times 1 is 1. 1 times 1 is 1. That's negative 5 when you add them. 1 times negative 5 is negative 5. That's negative 21. 1 times negative 21 is negative 21. That's negative 28. 1 times negative 28 is negative 28. That leaves me 36. 1 times 36 is 36. That's 96, which is not 0. Okay? So not this time. Now, x equals 1 is still a root to the original polynomial. Okay? So now that 1 is no longer giving us zeros, we move down to negative 1. So we do 1, negative 1, then 2, negative 2, and so on. So negative 1 goes in the box. I'm still trying this one. It's 1, 0, negative 6, negative 16, negative 7, 64, and 60. Let me move this over. Okay, so I'll add. Bring down the 1. 1 times negative 1 is negative 1. That's negative 1. When I add them up, negative 1 times negative 1 is positive 1. That's negative 5. Negative 1 times negative 5 is positive 5. That's a negative 11. Negative 1 times negative 11 is positive 11. That's 4. Negative 1 times 4 is negative 4. That's 60. Negative 1 times 60 is negative 60. That's 0. Okay? So, x equals negative 1. All right? I also have x to the 5th minus x to the 4th minus 5x cubed minus 11x squared plus 4x plus 60. X equals negative 1. That also needs to equal 0. Okay? So, negative 1 may still work for this one. So we'll try x equals negative 1. So negative 1 goes in the box. I have 1, negative 1, negative 5, negative 11, 4, and 60. Okay? Bring down this 1. 1 times negative 1 is negative 1. That's negative 2 when you add them. Negative 1 times negative 2 is positive 2. That's negative 3. Negative 1 times negative 3 is positive 3. That's got to be negative 8. Negative 8 times negative 1 is positive 8. That's 12. Negative 1 times 12 is negative 12. That's 48. No. Okay? Not this time. So not this time. Okay? So 1's out. negative 1's out. Let's try x equals negative 2, or x equals positive 2. So 1's out, negative 1's out, now we'll try 2. So I've got 2 I'm going to put in the box, and the polynomial is 1x to the 5th minus 1x to the 4th minus 5 x cubed minus 11 x squared 4 and 60. All right. So we'll bring down the 1. 2 times 1 is 2. That's 3. Oops, that should be minus 1. Okay, minus 1. I can make sure I copied the rest of it. Okay, so I did. All right, so I'm working on x to the 5th minus x to the 4th minus 5x cubed minus 11x squared plus 4x plus 60. So 2 times 1 is 2. That's 1 when I add them. 2 times 1 is 2. That's negative 3. 2 times negative 3 is negative 6. That's negative 17. 2 times negative 17 is negative 34. That's negative 30. 2 times negative 30 is negative 60. That's 0. Okay? That's what we need. So x equals 2. And I have x cubed, or I'm sorry, x to the 4th, minus x cubed, or plus x cubed, minus 3x squared, minus 17x, minus 30 equals 0. All right? So because the constant has changed, I'm going to revisit the p's and q's here. Okay? So p is all my factors of 30. That's 1, that's 2, that's 3, that's 5, that's 6, that's 10, that's 15, and 1. I'm sorry, 30. Division by 1 gives me the 30. Okay? Q is still 1. So plus or minus p over q is all the p's, but 1, negative 1 are out. They stop giving us zeros. Once they stop giving us zeros, they're out of consideration. Okay, so I'll try 2 again. Okay? So 2 is still on the list. 2 didn't stop giving us zeros, so we'll try 2 again. We're going to try in this polynomial. 1, 1, 1, 1, negative 3, negative 17, negative 30. Okay? So, bring down the 1. 2 times 1 is 2. That's 3. 2 times 3 is 6. That's 3. 2 times 3 is 6 again. That's negative 11. 2 times negative 11 is negative 22. That's negative 52. Not this time. So 2 failed to give us a 0. Now we're on to negative 2. So I still got the original polynomial, 1, 1, negative 3, negative 17, and negative 30. Okay? So I'll try 1. Negative 2 times 1 is negative 2. That's negative 1. Negative 2 times negative 1 gives me positive 2. That's negative 1. Negative 2 times negative 1 is positive 2. That's negative 15. Negative 2 times negative 15 is positive 30. That's 0. Okay? So x equals negative 2 is on the list. and we have x squared minus x, I'm sorry, this is x cubed, minus x squared minus x minus 15 equals 0. Okay? So, we mind our p's and q's again because the constant has changed. It's 1, so factors of 15, 1, 3, 5, and 15. Okay? So, Q is still plus or minus 1. So plus or minus P over Q equals all the P's, but X equals 1, negative 1 are out. How do we know that? They stop giving us zeros. Once they stop giving us zeros, or if they don't give us a 0, they're out for good. Okay? So, remember, I'm going to be working on this polynomial. Okay? So, 1's out, negative 1's out, 3 is first on the list. So, 1, negative 1, negative 1, negative 15. I better make those closer together. Okay, so I'll bring down this 1. 3 times 1 is 3, that's 2. 3 times 2 is 6, that's 5. 3 times 5 is 15. Add those up, you get 0. So x equals 3 is also a root, and I have x squared plus 2x plus 5 equals 0. Okay? I'm going to pause it and get another board. All right, I'm back with another board, and I've taken the liberty of copying this over to there, and we're going to note that this is not factorable. There's no pair of factors of 5 that add up to 2. So we're going to use the quadratic formula, x equals negative b plus or minus b squared minus 4ac all over 2a. In the context of this problem, a is 1, b is 2, c is 5. Okay. All right, so plugging into the appropriate formula, x equals negative 2 plus or minus 2 squared minus 4 times 1 times 5. Sorry about the shakiness of the board. Okay, so it's 2 times 1. Okay, under the radical is the first thing we do. That's going to be 2 squared minus 4 times 1 times 5. Okay, except for that the parentheses. So we have 4 minus 20, that's negative 16. Negative square root of 16 is, square root of negative 16 is 4i. Okay, so for the context of this part, or the problem, we have x equals negative 2 plus or minus 4i over 2. We rewrite this again. Okay, so x equals, division gives me negative 1 plus or minus 2i. Okay, so we have that. So that was the root to this, but we had other roots. Altogether, x equals, in order from least to greatest, we had negative 2, we had negative 1, we had 1 somewhere, we had 2, we had 3, and then we also had these two. So negative 1 plus or minus 2i. Okay? It was a 7th degree polynomial up here. We have a potential for 7 different solutions, and that's what we have. 1, 2, 3, 4, 5. And then the plus case is the 6th, the minus case is the 7th. Okay, now we also discussed Descartes' rule of signs. So you guys can rewind earlier if you want, but let me take this to where we did Descartes' rule of signs. I'm hoping it's visible. Again, I'm sorry if the monitor shakes. I'll put it down. So that was where we did Descartes' rule of signs. And let me put this back where it came from, where I just moved it from. Okay, I'm going to pause it. All right. So, anyway, the Descartes' rule of signs said that we had originally a potential for 3 or 1 positive real roots. We also had 4 or 2 or 0 negative real roots. The actual values, as you can see, is we actually had 3 positive real roots. We had 2 negative real roots. We had also had 2 non-real roots. These 2 were non-real roots. And that is the big picture of Descartes' rule of signs, rational root theorem, and all that good stuff. Okay? You will probably never be given a problem this complex.